Welcome back. This is lecture 5, page 5. So an important function, the absolute value. So for a real number a, the absolute value of a is its distance, is the distance from the origin, or from 0 to a. Okay, and that's what that means geometrically. So let me just put this out. The geometric idea, representation of that, is that if I have a number line, and I have 0 here in the middle, and I have some point A, then the distance between 0 and A I'm going to represent as the absolute value. Now what you'll notice is that this is actually symmetric about 0. So for example, if I go over to negative A, that's going to have the same distance from 0 as the positive A. So that's the distance there is going to be the same. So for example, if I said geometrically, what is the distance from 0 to 3? That's just going to be 3. Because again, if I draw a little number line, here's 0, and I go over 1, 2, 3. That distance there is 3 units away from 0. Negative 3 is actually the same. What you're going to notice is if I have 0 here and I have negative 1, negative 2, negative 3, it too is also 3 units away. So you'll see that it's actually a symmetric function about 0, which means it's even. Now in general, we have an algebraic definition. So this definition up here was geometric. What does it look like? How do you interpret that visually? And then here is the algebraic definition. The algebraic definition is if it's positive, you leave it alone. So you just say x. So if it's 3, the absolute value of 3 is 3. If it's positive, if x is greater than or equal to 0. Now this is where it gets a little weird for some students. If it's negative, you need to put a minus sign in front of it to make it positive. So it's actually negative x if x is less than 0. So note here, algebraically, what you're going to see is if you have the absolute value of negative 3, according to the definition, how do you make something positive? You slap another minus sign in front of it. That's going to make it positive. And that's where that minus sign comes from, because it's negative. So that becomes positive 3. Now knowing the algebraic and the geometric definition can really help you. So for example, if I said what is the absolute value of x over x, and I want to write that as a piecewise function. Now the first thing I'm going to note in this case is because I have an x in the denominator, I can't allow for division by 0. So x can't be 0. So of course the domain of this guy, the domain of f, is everything but 0. Union 0 to infinity. Okay, let's take a look at this function. So f of x is going to be equal to the absolute value of x over x, which is the same thing as saying 1 over x times, remember the definition of the absolute value of x, that's just going to be 1 over x times, now I have this piece, 1 over, let's see, that's just going to turn into x if x is greater than 0. Now notice I don't put the equal sign. You may say, why didn't I put the equal sign there? It's because I cannot have 0, right, because of the domain. So that restriction changes this a little bit. And negative x if x is less than 0. Now I bring the 1 over x inside, and that's going to turn into x over x if x is greater than 0, and negative x over x, again I just distributed that on the inside, if x is less than 0. Now x over x is just 1, so the whole thing simplifies down to 1 if x is greater than 0, and negative 1 if x is less than 0. And so knowing the algebraic definition like this can actually help simplify functions for us.